All right, algebra students, this is going to be the key to your review for the final exam. So, which class period had a lower median? So, this is problem number one here. The median, remember, is this middle line inside the box. So, the median in first period's right here, it looks like at about 80, and the median in period two is 85. So, the lower median is in first period. Its median is about 80, but second period's median is about 85. Which class period was more consistent with their scoring? Well, you can see consistency by how spread out the data is. So as you can see, second period's data is squished together more. The lowest piece of data, the lowest test score in second period is 70, and the highest is 95. Whereas in first period, the lowest is 60, and the highest is about 98, 97 and a half, something like that. You can also see that the box, which represents the middle 50% of data, is not as wide as the box for first period. So what I would say here is second period is more consistent. Its data is closer together. And that answers the second problem. Which class period typically scored higher? Well, the highest score in first period is higher, but the 75th percentile right here is higher than the 75th percentile there. The 50th percentile is higher than the 50th percentile there. The 25th percentile is higher than the 25th percentile there. And the lowest data score is higher than the lowest score there. So, second period typically scored higher. The lowest right here compared to there. 25th percentile here compared to there. Median or 50th percentile here compared to there. And 75th percentile here compared to there are all higher in second. All right. Calculate the mean, median, mode, range, and interquartile range for the following data. So it's going to be important to rearrange this data from smallest to biggest. So 1, 3, 4, 4, 5, 5, 5, 5, 5, 6, 7, 7, 9, 9, 12. So I've put it in the order. Now I'm going to get my calculator and I will calculate the mean. So I'm going to bring the screen in here. Just a moment. All right, so I have 1 plus 3 plus 4 plus 4 plus 5, 5, 5, 5, 5, 6, 7, 7, 9, 9, 12. I've added all those together, and it's 87 when I add them together. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points. So I'm going to divide that by 15, and I'll get 5.8. And that is the mean, or the average. The median is the middle data point. Since there are 15 data points, the middle data point will be the 8th. 1, 2, 3, 4, 5, 6, 7, 8. That 5 right there. This is the median. It's 5. The mode is the one that occurs most often. So the 5s here are the mode. The range is the biggest data point minus the smallest data point, which is 11. And the interquartile range takes the bottom half, well, it takes the 75th minus the 25th quartile. So we look at the bottom half of data and we find the median of that. And then we look at the top half of data, find the median of that. And that'll help us get started with the interquartile range. So here we have 7 data points. 1, 2, 3, 4, 5, 6, 7. 7 data points. So the fourth one will be our 25th percentile for the data. And in the top half of data, 1, 2, 3, the fourth one will be our 75th percentile. So we do, for the interquartile range, we do 7 minus 5, which is 2. That's our interquartile range. For problems 5 and 6, we're going to use this dot plot. Describe the shape of the dot plot. Well, if we kind of look at it like that, it looks pretty symmetric. That means that if you fold that across this line and take this, it looks pretty much the same on the right and the left across this line right there. Pretty close. So we say it's symmetric. We might also say it's normally distributed. It's a word we might use. And you'll learn more about that later. Yeah, there's one hump in the middle. Kind of is another way to think about it. How could you increase the standard deviation by moving 1 point? Well, remember, standard deviation is a measure of spread. How spread out is that data? And if you want to, so we need to spread the data out more. So if we take a point from the mean right in the middle and move it way out here, that will spread out the data. If instead of going there, we go even further, then that will increase the standard deviation even more. And the further away we get from the mean, the more we increase the standard deviation. So move a point from the mean far away. Because standard deviation is a measure of spread anytime we increase spread, we also increase standard deviation. All right, so, oh, I misspelled spread there. Sorry about that. All right, so that is all of the questions for the first page, all the one variable statistics. Now we're going to look at solving equations. So each of these is going to give us a little practice of solving. They get progressively more difficult. And remember, we're undoing operations or doing the inverse operations. So first, to get the 2x term by itself, I'm going to subtract 3 from both sides. This will make a 0. So I have 2x on the left is equal to 64 on the right. Now I have 2 times x. The inverse operation of multiplication is division, so I'll divide by 2 to undo the operation of multiplication, multiplying by 2. And I'll get x is equal to 32. It asks us here to check our solution, so I will plug my 32 back in for x. Whoops. And check and see that this comes out to be correct. 2 times 32 is 64, plus 3 is equal to 67. 64 plus 3 is 67, equals 67. That checks. That is question 7. Question 8. Now, I notice here that we have our x is divided by 2. And I'm going to have to deal with that. But first, I can move this over to the other side by just adding 5. So I'm going to add 5 to both sides. And that will give me x over 2 is equal to 2. All right, so now we have x over 2 equals 2. So we have an unknown value divided by a number. So to undo the operation of division, we multiply. We multiply by 2, and that'll make this a 1. It'll make it a 1x is equal to, oh, and we have to multiply both sides by the 2. So it'll be x equals 4. And so that is our solution for number 8. Number 9, we need to get all of our x terms to one side of the equation. So I'll add 2x to make a 0 here. But if I add 2x on one side, I need to add 2x on the other. And I have 6x minus 7 equals negative 1. Now I need to get this x term by itself, so we undo the operation of subtracting 7 by adding 7 to both sides. So we get 6x is equal to 6. Now we're multiplying x by 6, so to undo that operation, we divide by 6. 6 divided by 6 is 1. Number 10. Here we have two fractions equal to each other. That's called a proportion. So in this proportion, I'm going to get x by itself. Right now it's being divided by 8. So I'm going to multiply by 8 to undo that operation of division. And I can really think of it as 8 over 1. Multiplying by 8 is multiplying by 8 over 1. So on the left-hand side, we'll just have x. And on the right, multiplying fractions, we multiply across the numerators. That's 72 over, across the denominators, 12 times 1 is 12. And 72 divided by 12 is 6. So our answer is 6. Oops, I did not check my work on the last problem, the last 3. So let me go back and do that. Sorry about that. I have a 4 over 2 is minus 5 is equal to negative 3. Well, 4 divided by 2 is 2. Minus 5 equals negative 3. 2 minus 5 is negative 3 equals negative 3, and that checks. With this one, we have 4 times 1 minus 7, so I'm just plugging the 1 in for x in my original equation, is equal to negative 2 times 1 minus 1. This is 4 minus 7, negative 3. This is negative 2 minus 1 is negative 3. That checks. Again, plugging in 6 into the original equation there. So we have 6 over 8 is equal to 9 over 12. Well, if I take this fraction and I'm going to divide the numerator by 2. And the reason why is that 6 and 8 are both divisible by 2. So I want to rewrite that fraction in reduced form. So I'm going to divide both by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And that's going to be equal to, on the other side, 9 and 12 are both divisible by 3. So I'm going to write it in reduced form, lowest terms. But it's not really reduced, it's really lowest terms. By dividing by 3, they're both divisible by 3. 9 divided by 3 is 3. Over 12 divided by 3 is 4. And that checks. All right, so I've checked my work now on those. Let's go to number 11 here. I need to distribute my 4 to each of the things inside the parentheses. I'll get 8x plus 12 is equal to 8x minus 5. I'm going to get all my x terms on one side. However, when I do that, this makes a 0, and this makes a 0, so I'm just left with 12 equals negative 5. When that happens, that's not true. 12 never equals negative 5. So there are no solutions to this equation. And what that means is there's no number that I could plug in for x that would make this equation true. No number whatsoever. There's nothing for me to check. I cannot check all the solutions to determine that none of them work. It's impossible. There's an infinite number of possibilities. So there's no way to check that one. On this one, I have to distribute the 4. I get 4x plus 24 plus 2x equals 24. Now I'm going to combine my x terms. I'll get 6x plus 24 equals 24. I need to get my x term by itself, so I'll subtract 24. I'll get 6x equals 0. Now I still have 6 times x. So to isolate my x, I divide by 6. And I get x equals 0 divided by 6 is 0. So now I have to take that 0 and plug it back into my original equation and see if it comes out to be true. All right, so 4 times the quantity, 0 plus 6 plus 2 times 0 equals 24. All right, 0 plus 6 is 6. 6 times 4 is 24. Plus 2 times 0, well, 2 times 0, that's 0. So I'm not adding anything. And that equals 24, and that checks. All right, in this problem, we have two fractions equal to each other, so it's, again, a proportions problem. So I'm going to multiply both sides by 3 in order to make a 1 over here. So I'll just get x plus 5 on the left, and that equals, now, this multiplying by 3 is the same as multiplying by 3 over 1, so I'll get 3x in the numerator over 4. Now I need to get my 3x term by itself. Right now it's being divided by 4, so I multiply by 4 to undo that operation. Here I can distribute. I'll get 4x plus 20 is equal to, since this makes a 1, it's just equal to 3x. Now I'm going to, there's really a couple options here. I could subtract 20 from both sides. I could, and, well, first I'm going to subtract the 3x. I could have subtracted the 20. I could have subtracted the 4x. All of those are good moves. But here I get x plus 20 is equal to 0. Now, I wanted to do it this way because I've had folks who they forget that it equals, they lose their equal sign here. Like, where did it go to? But we need to remember that what we did equals 0 because 3x minus 3x is 0. Now we can subtract 20 from both sides, and we get x equals negative 20. We're going to check our work by plugging in negative 20 into x in our original equation. So we have a negative 20 plus 5 is going to be negative 15 over 3 is equal to negative 20 over 4. Well, that's negative 5. And negative 15 over 3, that's negative 5, equals negative 5. And that's true. Looks good. Here we distribute the 3. We get 3x minus 12 is equal to 12. I'm going to add 12 to both sides. I'll get 3x equals 24. Divide by 3 to undo the operation of multiplication. I get x equals 8. So I'm going to plug that back into the original equation. So I have 3 times the quantity, 8 minus 4 equals 12. Well, 3 minus 4, that with 8 minus 4, that's 4. So we have 3 times 4 equals 12. 3 times 4, that's 12, equals 12. It checks. All right. That is page 2 done. Page 3, calculate the slope. So we have 2 points here. We'll say a blue and a red point. And the slope, remember, is calculated as delta y over delta x. where delta y is calculated as y1 minus y2 over x1 minus x2. And it doesn't matter. It could be y2 minus y1 over x2 minus x1. It doesn't make any difference. That's fine. What can't happen is y2 minus y1 over x1 minus x2. So notice these are not from the same point, and these are not from the same point. But here, these are from the same point, and those are from the same point. So I will call my blue point here, I'll call that my first point, x1, y1, and my red point will be x2, y2. So y1 is 4 minus y2 is 8 over x1 is 3 minus x2 is 8. 4 minus 8 is negative 4. 3 minus 8 is negative 5. So our slope, well, a negative divided by a negative is a positive. Now, if you had done it the other way and done 8 minus 4 over 3 minus 8, you would have gotten 4 over 5 right away, and you wouldn't have had to do this step. But it doesn't make any difference, really. So our slope here is 4/5. Whoops, 4/5. Now in our table, what we see is that our x's, our delta x in the table is +1. I'm going to use the same color to show that the same thing is happening. Our delta y, the change in y, is +0 or -0. And I'm going to use that same color to show that the same thing is happening. Remembering that slope is delta y over delta x, we get 0 over 1, which is equal to 0. 0 divided by any number is 0. So our slope is 0. On the graph, zooming in real close there, we can see that from this point down to that point, whoa, that's way too big. There we go. Our delta y, we're going down 1, 2, 3, 4, 5, 6. So our delta y is -6. Whenever we're going down, the delta y is negative. And our delta x is to the right 1, remembering that slope is equal to delta y over delta x. -6 over +1 equals 6, or -6, excuse me. So here our slope is -6. All right. So here in this one, we're asked to identify the slope and the y-intercept and then graph. So the slope is always the number right in front of x. That's our m value. So in this case, it's 2/3. And the y-intercept, the b there, tells us the y value in our point. So our y-intercept is the point 0, 1. So we can plot that there. 0, 1 is right there. And then we can use our slope of 2/3. That says to go up 2 and to the right 3. And then there will be another point there. Up 2 and to the right 3. And there will be another point there. And we can follow that just like that. We can also go down 2 and to the left 3. So down 2 and to the left 3. Down 2 and to the left 3. And follow that pattern in that direction. Then we can just connect those with a straight line. And there is our graph. For this one, our slope is negative 1/2, and our y-intercept is the point 0.07. So 0.07 is going to be right there. And a slope of negative 1/2 says go down 1 and to the right 2. And there's a point, down 1 and to the right 2. Just keep following that pattern. Or up 1 and to the left 2. And follow that pattern that way. And we can then connect that right there. On C, our slope is 2. Our y-intercept will be the point 0, negative 7. So 0, negative 7 is right there. Whoops, I want to use that red. 0, negative 7. With a slope of 2, that means go up 2 and to the right 1. Up 2 and to the right 1. We can just follow that pattern. We can also think of it as up 4 and to the right 2. That also works. And there we go. Bob the puppy was born and weighed 2 pounds. Each month he gains 4 pounds. Write an equation in slope-intercept form to represent the situation. So here, the M and the B, well, he was born weighing 2 pounds. So when he was born, that's our starting value. He weighed 2 pounds. Each month, he gains 4 pounds. So that's going to be our slope. So our equation then is going to be y equals m, increase of 4 pounds per month, plus b is plus 2. Now we're going to use that equation to calculate how much he will gain in 15 months. So here our x is the number of months and y is the weight. So we can plug in then an x value of 15. So I'm going to use 15 months there. So it'll be 4 times 15, and then plus 2. Well, 4 times 15, that's 60, plus 2 is 62, so that's 62 months. In 62 months, he will weigh, in 15 months, in 15 months, he will weigh 62 pounds. I'm going to just erase that because I'm getting in the way of my graph there. Use your equation to calculate how many months it will take for him to weigh 150 pounds. So now he wanted to weigh 150 pounds. So in our equation, that will be the y value. So 150 is equal to 4 times x plus 2. So I'm going to subtract 2 to get the 4x by itself. That will be 148 is equal to 4x. Dividing both sides by 4, 148 divided by 4 turns out to be 37 equals x. So it will take him 37 months to weigh 150 pounds. All right, to graph this situation, well, X, that's my months, number of months since birth, and Y is the weight in pounds, and I'll put LBS for pounds. I'm also going to put, there's 1 month, 2 months, 3 months, like that. But in pounds, I'm going to start off 1, 2, 3, 4. There's 5, and there's 10. All right, so my B value, the y-intercept there, is 0, 2. So at birth, Bob was 2 pounds, and each month, so to the right 1 month, he gains 4 pounds. So right there is going to be another point. Oh, I should choose a different color there, sorry. And then in this, after 2 months, he'll be 10 pounds because he will have gained another 4 pounds. That's going to go like that for a while. It wouldn't make sense to go that direction because that would mean he was negative months old, and that doesn't make sense. So that's where we are right now. On to the last page. If you've stuck with me this long, way to go. I hope it's helping. All right. Write an equation in point-slope form of this graph. All right, so point-slope form is y minus y1 is equal to the slope times the quantity x minus x1, where x1 and y1 are any point. So I'm going to use this point right here. No, I'm going to use this point right here, the point 3, 1. So my equation is y minus y1. My y value is 1. So y minus 1. And I put it in parentheses mainly because if it's negative, we really want it in parentheses. Equals, and we need to figure out the slope. So I'm going to put in the slope triangle here. And I'm going to look at it from left to right. So I'm going this direction. So I'm going down. That means my delta y is negative. It's going to be negative 2. And my delta x is going to the right, which means my delta x has to be positive 3. So my slope, delta y over delta x, is negative 2 over 3. And then times the quantity, x minus x1. Well, my x value is 3. And again, I'm going to put it in parentheses just to be clear. So it's y minus 1 equals negative 2/3 times the quantity x minus 3. And if my points were negative, then putting it in parentheses here would be particularly helpful if the values of those points were negative. All right. Now we're going to write an equation of a line with a slope of negative 4, and through that point, 5, 7. Okay. So again, it's y minus y1. Well, my y value there is negative 7, is equal to the slope, m, times the quantity x minus x1. Well, my x value is 5. Y minus 7 is y plus 7 is equal to negative 4 times the quantity x minus 5. And so there is that equation. All right, so we have points written in standard form. You can either change them to slope-intercept form by solving for y and then graph them. All right, so this one really lends itself to solving for y because there's no the coefficient is 1 on y, which makes solving for y really simple. We just subtract 3x, we get y equals negative 3x plus 5. Now, we could have written y equals 5 minus 3x, but that's not in y equals mx plus b form, so we want to write it like this. My slope is negative 3, and here my b value tells me that I'm going to have a point 0.05, and my slope of negative 3 says go down 3 and to the right 1, down 3 and to the right 1. I can also go up 3 and to the left 1. Now I can connect those like that. And this one, here I'm going to graph differently. I'm going to find the y-intercept. I'm going to find the y-intercept by plugging in 0 for x. So 5 times 0, plugging in 0 for x will allow me to find the y-intercept. Plus 2y equals 8. Now I'm going to, 5 times 0, that's 0. So I have 2y equals 8. Now I'm going to divide by 2 to get y by itself, and I get y equals 4. And this tells me that my point, my y-intercept, is the point, well, my x value was 0. I decided that right here. And my y value is negative 4 right here. So when x is 0, y is is positive 4, not negative. All right. Now I need to find the x-intercept. And the way that I do that is by plugging in 0 for y. So I have 5x plus 2 times 0 equals 8. 2 times 0 is 0, so I have 5x equals 8. Now I'm going to divide by 5 to isolate my x, and I get x equals 8/5, which is 1 3/5, or 1.6. And so that tells me that the point that I have is the point 1 3/5, 0, because we chose 0 for y, and then x equals 1 3/5. So we have 2 points there. We have the point 0, 4, and we have the point 1 3/5, 0. That's 1.6. So like right there. And strictly speaking, all I need to do is connect those 2 points like that. I could do more to try to figure out other points on the graph, but I think we can save that for another time and call that the end of the video. I hope that this all helped. Thanks for watching.